In our previous lesson, meron tayong method to estimate the area of a region S by subdividing it into approximating rectangles. So observe that as the number of rectangles increases, the estimates gets closer to the exact measure of the area. However, yung values na makukuha natin doon, estimate lang yon. Hindi yun yung talagang area ng ating region. So, ang goal natin ngayon is to solve for the exact area of an irregular region. So, dito sa ating figure, yung red part dito, yun yung parts na hindi nasama doon sa pagkuha natin ng area. So, the question is, how do we fix this issue in order for us to solve the exact measure of the area under this curve? To generalize what we have learned from the previous lesson, let's consider this general region S. Okay? So, we divide S into n number of strips. So, meron tayong n number of strips dyan. And those strips have the same width. At yung width of the interval AB is actually B minus A. Diba? Kasi nga, itong region natin is from A to B. So, pag kinuha natin yung width ng interval natin, that is just, ima-minus lang natin B minus A. Tapos, it implies that the width of each strip is actually equal to delta x. Okay? So, ano yung delta x na yon? That is actually equal to b minus a over n. Ima-minus natin yung width ng interval natin divided by kung ilang mang rectangles yung gusto natin. So, that is the width, okay, of our strip. And that is delta x. Also, the values of x are divided into n sub-intervals. Now, we draw rectangles whose widths are equal to delta x and whose lengths are the same as the right edge of the strip. The measure of the lengths of the rectangles corresponds to the values of the function at f of x sub 1, f of x sub 2, hanggang f of x sub n. So, dito, since na-divide na natin siya into n rectangles, at alam natin na yung width natin is delta x, so ito yung delta x natin, yun namang ating length, yung function value at the right. Okay? Pwede rin namang at the left, bahala kayo kung gusto niyo. So, dito, sa first rectangle natin, f of x sub 1 ng ating length. So, delta x times f of x sub 1 yung kanyang area. Sa pangalawa naman, delta x pa rin yung width. So, we have delta x times, ang length naman niya is yung function value at x sub 2. So, delta x times f of x sub 2. Now, if we get the sum of those rectangles, we have r sub n is equal to f of x sub 1 delta x plus f of x sub 2 delta x plus f of x sub 3 delta x plus up to f of x sub n delta x. So tulad ng sinabi natin dun sa ating previous lesson, this approximation gets better as the number of rectangles n increases without bound. Ibig sabihin nun, as n approaches infinity, yung ating area gets close to the exact measure. So as n approaches infinity, yung ating red dito na part, which is actually the error sa pagkuha natin ng area, approaches 0. While the amount of space highlighted in blue, ito naman, approaches now the exact measure of the area under the curve. So we realize this by applying a limiting process to accurately determine the area of the region that lies under the curve. So, yung palang ibig sabihin nun, no? Kapag kinuha natin yung sum ng mga strips. Okay? And we take the limit of that as n approaches infinity, we are actually getting the exact measure of the area. So the area now is actually equal to the limit as n approaches infinity of the sum of the areas of the strip. So that is the limit as n approaches infinity of f of x sub 1 delta x plus f of x sub 2 delta x up to f of x sub n delta x. This leads us now to our definition number 1, which says that the area A of a region S that lies under the graph of a continuous function f is the limit of the sum of the areas of approximating rectangles as the number of rectangles n increases without bound. So that is area equals the limit as n approaches infinity of the sum of f of x sub I delta x from I equals 1 up to n, or that is the limit as n approaches infinity of f of x sub 1 delta x plus f of x sub 2 delta x plus up to f of x sub n delta x. And it doesn't matter kung gagamitin mo yung left or yung right or yung midpoint or actually any point on the strip. Kasi nga, lahat yun, ibibigay pa rin sa'yo yung exact measure of the area provided that you get the limit of the summation of those rectangles as n approaches infinity. Let's solve the exact measure of the area of the region S that lies under the curve f of x equals x squared and above the x-axis from x equals to 0 to x equals 1 using the definition of area. Visualize kung ano yung itsura ng ating graph. So, ito yung area na hinahanap natin. So, this is our f of x. Tapos, from 0 siya hanggang 1. At hinati natin siya into n number of strips. So, theoretical lang ito. Hindi ito yung exact number of n, pero let's say we have n. So, for our solution, we first have to get the width. And what is the width? The width is delta x. From our formula, we just divide 1 minus 0, okay, the length of our interval, divide it by n. So, that is 1 over n. So, ang width ng bawat isang strip dito is 1 over n. Now, the length is f of x sub I equals x sub I squared. So, here, we are using the right end point. So, x sub 1 natin is actually equal to 1 over n. Tapos, yung x sub 2 natin is 2 over n. So, yung length natin is, for the first rectangle, we have 1 over n squared. Kasi nga, yun yung ating function value. Kasi ang function natin is x squared, di ba? So, 1 over n squared. Yung second na length natin is 2 over n squared up to n over n squared. So, we know that our width is 1 over n at yung length natin is x sub I squared. So, we now have the summation of f of x sub I delta x from I equals to 1 up to n is now 1 over n squared times 1 over n. So, ito yung length ng first rectangle. Ito yung width. Plus 2 over n squared times 1 over n. Ito naman yung ating length for the second rectangle. Tapos ito yung width. Up to the last rectangle, which is n over n squared length, 1 over n width. So, if we simplify that, we have 1 over n squared times 1 over n plus 2 squared over n squared times 1 over n plus up to n squared over n squared times 1 over n. So, pinasok lang natin yung square dito sa loob ng mga ito. With that now, we have, pwede natin ilabas yung 1 over n, right? Kasi, lahat naman ng terms natin may 1 over n. So, we have 1 over n times, ang naiwan sa loob ay 1 over n squared plus 2 squared over n squared up to n squared over n squared. But notice that lahat ng terms dito sa loob merong n squared sa baba. Or they have a factor na 1 over n squared. So, pwede ulit nating ilabas yun. So, we now have 1 over n times 1 over n squared at naiwan sa loob yung 1 plus 2 squared plus up to n squared. And we know that by mathematical induction, 1 plus 2 squared plus up to n squared is actually equal to n times n plus 1 times 2n plus 1 all over 6. Pero we will not show it here na kung paano siya naging ganyan. Pwede nyo siyang gawin as exercise para show that this is actually equal to this. Now, since eto equal siya dito, pwede nating palitan ngayon. So we have 1 over n times 1 over n squared times n plus 1 times 2n plus 1 all over 6. So if we simplify that, that is just equal to n plus 1 times 2n plus 1 over 6n squared. Kasi nga, pwede naman itong matanggal. So that is now the summation of f of x sub I delta x from I equals 1 to n plus 1 times 2n plus 1 all over 6n squared. Pero hindi pa dyan nag-end yung ating solution. This is just the summation. To get the area, sabi niya kanina, we have to get the limit of this summation as n approaches infinity. So, we now have the limit of n plus 1 times 2n plus 1 all over 6n squared as n approaches infinity. So, that is equal to, so pwede natin ngayong paghiwalayin yung n squared, gawing n times n, tapos yung 1 over 6 na constant, pwede nating i-separate. So, we have 1 over 6 times n plus 1 over n times 2n plus 1 over n. O, diba? That is just equal to n plus 1 times 2n plus 1 all over 6n squared. Ginawa natin yan kasi gusto natin na yung n plus 1 over n, maging ganito yung itsura niya. 1 plus 1 over n. At yung 2n plus 1 over n, ganito yung maging itsura niya. Why? Kasi alam natin yung limit ng 1 over n as n approaches infinity, that is just equal to 0. Okay? From your differential calculus. So, if we get the limit of that, we have 1 over 6, limit of a constant is just the constant, times limit of 1 is 1, plus limit of 1 over n is 0, kasi nga n approaches infinity, and the limit of 2 is 2, limit of a constant, plus the limit of 1 over n, again, is 0. Okay? So we now have 1/6 times 1 times 2, or that is 1/3. Therefore, the exact measure of the area of S is 1/3 squared units. So going back to our first definition, ito yung formula natin for the exact measure of the area. Actually, the expression summation of f of x sub I delta x from I equals 1 to n is actually called the Riemann sum, and it was named after George Bernard Riemann. So we are actually using Riemann sum in finding the lower estimates, the upper estimates, or the exact measure of the area under the curve. This leads us to our second definition, which states that if f is a function defined on an interval ab, the definite integral of f from a to b is given by the integral from a to b of f of x dx equals the limit as n approaches infinity of the Riemann sum. Provided na itong limit na ito exists, and if this limit exists, then it is said that f of x is integrable on the interval ab. So sinasabi lang niya yung definite integral ng isang function over an interval is actually yung limit no Riemann sum natin as n approaches infinity. And the integral symbol, itong symbol na to, was actually introduced by Gottfried Wilhelm Leibniz, who co-discovered calculus. So it is an elongated S, okay, na para siyang pinagsamang L at saka S, L for limit and S for sum. So in this definite integral, f of x is called the integrand and a and b are called the limits of integration, such that a is the lower limit and b as the upper limit. And we call this process of calculating the integral as integration. So from the definition, we can actually see that the definite integral is equal to the area under the curve of f of x from a to b. If f of x is greater than or equal to 0. So, ibig sabihin, yung pala ng ating definite integral, yun pala yung area ng curve. Basta yung hinahanap nating area is above the x-axis. So, ibang usapan kapag yung area naman is nasa baba ng ating x-axis. So, remember that. The definite integral of f of x dx from a to b is actually the area under the curve if yung area natin is above the x-axis. So in this particular figure, kasi meron tayong region dito na below y equals x cubed minus 6x squared plus 11x minus 1. And that area is from 1 to 3. So by the definition, this area is actually equal to the definite integral from 1 to 3 of x cubed minus 6x squared plus 11x minus 4 dx. Ulitin ko lang ulit, yung definite integral interpreted as the area under the curve is only true if yung area na hinahanap natin is above the x-axis. If the area is below the x-axis, then yung definite integral natin can be interpreted as a net area. Or ibig sabihin nun, that is the difference of area 1 and area 2. So actually pala, yung area above the x-axis, positive yun na area. Tapos yung area below the x-axis, negative yung area na makukuha natin. That is why, kapag kinuha natin yung area ng buong ito, so negative ito, positive ito, ang ginagawa niya, pinagmaminus niya yung dalawang area. So, pwede na makakuha tayo actually ng area na negative. So, in this case, if we are getting the definite integral from 0 to c sub 2, so we have the definite integral from 0 to c sub 2 of f of x dx is actually equal to area 1 minus area 2. Let's evaluate the definite integral from negative 4 to 4 of the square root of 16 minus x squared dx. Visualize first the graph para alam natin if we can actually interpret this as an area or a net area. So in this case, kita nyo naman na yung graph ng ating f of x is a semicircle above the x-axis. So we can interpret this as the area. So for our solution, the definite integral from negative 4 to 4 of the square root of 16 minus x squared dx is just equal to, since semicircle to, at ang radius natin is 4, we can actually use the formula for the circle and then divide it by 2. So that is pi r squared divided by 2. So we have 1 half times pi times the radius is 4 squared. So that is just equal to 1 half pi times 16 or 8 pi. So ang ginawa lang natin dito, in-evaluate natin yung integral using the known formula for area. Now let's evaluate the definite integral from negative 1 to 1 half of 2x plus 2 dx. So from our figure, kita naman natin na this is above the x-axis. So we can interpret this as the area. And by looking at the figure, this is just a triangle. And we know that the formula for the area of a triangle is just 1/2 base times height. So for our solution, the definite integral from -1 to 1/2 of 2x plus 2 dx is equal to 1/2 times base. Ang base natin dito is 1.5 or 3/2 times height. Ang height naman natin is 3. So, pwede na natin ngayong i-simplify that, and that is just equal to 9/4. Let's evaluate the definite integral from 0 to 3 of x cubed minus 6x dx. So, as seen in the figure, we can interpret this as a net area. Okay, kasi meron tayong area sa baba at area sa taas. Also, hindi naman ito regular polygon. We cannot use the known formulas for area. So to evaluate this, we have to use the definition of area, which is the limit of the Riemann sum. So for our solution, kunin muna natin yung width natin, which is delta x. Since ang ating interval is from 0 to 3, so we minus that over n, so we have 3 over n. And the length is yung function value natin, pwedeng sa right or sa left, bahala kayo. But in this case, we will use the right. So the length is f of x sub I, so that is f of 3i over n, because our x sub 1 is 3n, our x sub 2 is 6 over n, our x sub 3 is 9 over n, up to x sub I, which is 3i over n. So kapag pinasok natin yung 3i over n sa ating function, our length now is the cube of 3i over n, so galing lang yun dito, minus 6 times 3i over n. Our definite integral is actually equal to the limit as n approaches infinity of the sum of f of x sub I delta x from I equals to 1 up to n. Or that is the limit as n approaches infinity of the sum of f of 3i over n times 3n. Kasi ito yung length natin, di ba? At ito yung ating width. Or, pwede natin ilabas yung 3 over n. We have the limit as n approaches infinity of 3 over n times the summation of f of 3i over n. So with that, pwede na natin ngayong kunin yung value ng f of 3i over n, which is 3i over n cubed minus 6 times 3i over n, para makuha natin yung summation and then the limit. And that is, pag pinasok natin yung cube, 27i cubed over n cubed minus 6 times 3i is 18i over n. Okay? The summation of that times 3n, and then we get the limit as n approaches infinity. Now, pwede natin actually ipasok yung summation kasi yun yung property ng summation. So we have the limit as n approaches infinity of 3 over n times yung summation of 21i cubed over n cubed minus yung summation ng 18i over n. So since meron na tayong dalawang terms dito, pwede nating ipasok yung 3 over n or i-distribute siya dito at dito. We have the limit as n approaches infinity of 3 over n times the summation of 27i cubed over n cubed minus 3 over n times the summation of 18i over n. Pwede nating ilabas yung 27 over n cubed at yung 18 over n. So we have the limit as n approaches infinity of 3n times 27 over n cubed times the summation of I cubed minus 3 over n times 18 over n times the summation of I. And by mathematical induction, the summation of I cubed here is actually equal to the square of n times n plus 1 over 2. And this summation is actually equal to n times n plus 1 over 2. So with that, pwede natin ngayong palitan itong dalawang to nung mga to. So we now have, by simplifying this, the limit as n approaches infinity of 81 n raised to 4 times yung equivalent nito na square of n times n plus 1 over 2 minus 54 over n squared times yung equivalent nito na n times n plus 1 over 2. And pwede actually nating ipasok yung 81 over n raised to 4 dito sa ating dito. Okay, we just have to take the square root kasi naka-square to. Eto, pwede rin nating ipasok sa loob. Since nandyan na sila sa loob, pwede na natin itong i-cancel. Pwede na itong i-cancel. Which leaves us with the limit as n approaches infinity of the square of 9 times n plus 1 over 2n minus 54 times n plus 1 over 2n. Ngayon, pwede nating ilabas yung 9 halves, okay, squared. So that is 81 over 4 times n plus 1 over n squared minus, pwede rin nating ilabas yung 54 over 2 which is 27 times n plus 1 over n. Kasi gusto natin na itong dalawang to maging 1 plus 1 over n. So we have the limit as n approaches infinity of 81 times 4 times the square of 1 plus 1 over n minus 27 times 1 plus 1 over n. Yung limit ng 81 over 4 is just 81 over 4 times the limit of 1 is 1 plus, eto is 0 squared minus limit of 27 is just 27 times limit of 1 is 1 plus ito is 0. So we now have 84 times 1 minus 27 times 1. So that is negative 27 over 4. Or that is negative 6.75. So baka nagtataka kayo, di ba? Yung definite integral natin is considered as area. So bakit negative? Again, going back to the figure, this is interpreted as a net area or the difference between area 1 and area 2. And obviously here, mas malaki yung nasa baba. Kaya negative yung ating sagot. And finally, i-compare natin ngayon yung definite integral sa indefinite integral. So for our first solution, so by using our antiderivative theorems, pwede nating paghiwalayin yan. So we just have x raised to 4 over 4 minus 3x squared plus c. While for letter B, alam natin that definite integral is negative 6.75. So actually, ang pinupoint lang dito is, if we are getting the indefinite integral, ang ating result is just the general antiderivative. While if we are taking the definite integral, meron talaga tayong value na makukuha. Meron tayong number na makukuha.